Oxidation and reduction. Many types of substances give reactions called oxidation and reduction. Let us learn more about these reactions. 2 Mg plus O2 gives 2 MgO, statement 20. C plus O2 gives CO2, statement 21. MgH2 gives Mg plus H2, statement 22. CH3 minus CH3 gives CH2, that is equal to CH2, statement 23. In the reactions 20 and 21, a reactant combines with oxygen, whereas in 22 and 23, hydrogas is removed from the reactant. All these are examples of the oxidation reaction. The chemical reaction in which a reactant combines with oxygen or loses hydrogen to form the product is called oxidation reaction. Some oxidation reactions are brought about by use of specific chemical substances. For example, CH3 minus CH2 minus OH on oxidation gives CH3 minus COOH, statement 24. Here, the acidic potassium dichromate makes oxygen available for the oxidation of the reactant ethyl alcohol. Such chemical substances which bring about an oxidation reaction by making oxygen available are called oxidants or oxidizing agents.
Corrosion. Corrosion is the slow conversion of a metal into undesirable compounds after reacting with moisture and other gases that are present in the surrounding atmosphere. The rusting of ordinary iron is the most common form of corrosion. In moist air, iron will combine with oxygen and water to form hydrated iron oxide, a brownish-orange deposit of rust. Let's look at the conditions under which corrosion can occur. For this, you will need 3 clear iron nails, 3 test tubes, 3 rubber stoppers, cooking oil, calcium chloride, and distilled water. Begin by placing the 3 iron nails into the test tubes, which should be labeled A, B, and C. In test tube A, add distilled water such that only half of the nail is immersed. In test tube B, fill it with distilled water, completely immersing the nail. Add a few drops of oil so that a layer is formed on the surface of the water. This arrangement will prevent air from mixing with the water. In test tube C, add only calcium chloride, which will absorb moisture. Seal each of the test tubes with rubber stoppers. After 2 days, observe the nails. The nail in test tube A will show evidence of corrosion and be covered in brownish red rust. In test tubes B and C, the nails will not show any corrosion. For the corrosion of iron to take place, both moisture and air are necessary. In test tube A, both are present, which leads to the rusting of the nail. In test tube B, moisture is present, but the layer of oil acted as a barrier preventing the oxygen from mixing with the water. Therefore, the nail did not rust. In the third test tube, the air was dry because calcium chloride absorbed moisture, so the nail did not corrode. With this experiment, we can infer that air and moisture together will corrode metals. To prevent corrosion, metal surfaces will often be coated with paints or electroplated with non-corrosive metals such as nickel. Summary. The corrosion of iron will occur in the presence of water and oxygen. Corrosion can be prevented by electroplating or painting the surface of the metal.
Rusting. Rust is a chemical reaction that is probably very familiar to most of you. An old iron gate is likely to get deposits of brown flakes on it. An old car that hasn't been taken care of may have similar brown spots all over it. The brownish substance that forms over iron metal is called rust. In chemical terms, rust is iron oxide, which results when iron reacts with the oxygen and moisture in the surrounding air. Not all metals will rust. Aluminium and gold, for example, will not rust. Rusting is a process requiring both oxygen and moisture.
Let us look at some familiar occurrences around us to understand some chemical reactions in everyday life. Have you noticed fruits changing color when kept in open atmosphere for a long time? For instance, apples, bananas, and oranges. Have you seen bread going stale with black spots all around it? Have you seen milk turning into knots and break? Have you seen old metal screws turning reddish brown over the period? Be it a fresh fruit, packaged food, or metal objects, all these develop undesirable changes when kept in open atmosphere. When food or fruit is kept in the open atmosphere for some time, its taste and smell changes. This is known as rancidity. Whereas when a metal kept in open atmosphere undergoes a change, for example, a reddish brown powder coat appears on iron, this reaction is called rusting. What happens in the human body if rancid food is consumed? Is there a connection between food and open atmosphere? Yes, there certainly is. Rancidity occurs mainly due to oxidation. This happens because the fat in these food items gets oxidized by the air. This process is called rancidity. Rancidity is the redox process which develops unpleasant odor and flavors in food. Rancid fat in the body may cause health conditions, both long-term and short-term, leading to vitamin deficiency, muscle pain, diarrhea, and so on. It is most commonly believed to cause thickening of tissue, leading to high risk of heart-related ailments. Let us know more about the changes taking place during the process of rancidity. Light in UV range accelerates the initial step in lipid oxidation. Let us now learn about hydrolytic rancidity. Triglycerides present in lipids are hydrolyzed to release fatty acids during hydrolysis. One of the ways of preventing or controlling rancidity is to decrease the rate of oxidation by keeping the food item away from the light. The other controllable factors are heat and moisture. Let us see the change in foods using pH scale. The pH scale is to specify alkaline and acidic properties of chemicals present in any substance. The pH scale ranges from 0 to 14 with neutral at 7, acidic for less than 7 and alkaline for greater than 7. Here, this picture demonstrates the changes in foods using pH scale.